let's talk about interest. We've got two equations for interest. This first one is for compound interest. A is the amount of money. P is the principal, which means the amount you start with. 1 plus R over N. R is the interest rate written as a decimal. N is the number of times per year that the interest is compounded. Means the same thing here. And T is the time in years. Then this bottom one is also for interest, but this is for interest that's compounded continuously. So anytime you see the word continuous or continuously, that means that you have to use this other formula. Okay, so this is just regular compounding. And this is continuous compounding. I call this the PERT formula for obvious reasons, right? It looks like PERT, which is a type of shampoo. But anyway, so the PERT formula is used whenever you see the word continuous. Regular compounding formula is used when you don't see that, okay? Another thing I want to point out about the regular compounding is if we were instead showing decay, right, as opposed to growth, which is what this shows, if we were showing that something was decaying or getting smaller, then this plus sign would become a minus. Okay, so let's try some. Sal bought a house for $700,000. Over the last 5 years, the values of homes in his neighborhood have increased in value by 4% a year. Write an equation to calculate the value of his house after those 5 years. So remember, here's our formula. A equals P 1 plus R over N to the NT. So Sal bought a house for $700,000. There's our P. Over the last 5 years, there's our T. The values of homes in his neighborhood have increased in value, so we're increasing, which means we have a plus sign, by 4% a year. So 4% is our rate, and we write it as a decimal. And per year is our compounding, which means it's only compounded once every year, so N is equal to 1. Write an equation to calculate the value of his house after those 5 years. So now let's just plug everything into our equation. A equals P, right? I'm following this equation up here. So the first thing I need is P. I'm going to put a P right in here, and our P is 700,000. Okay, and then I have 1 plus R over N. So that's going to be 1 plus R over N raised to the N times T. So if I simplify this, 0.04 over 1 is just 0.04. And when I add that to 1, I would get 1.04. And my exponent, 1 times 5, is 5. So we pick this one. Be very careful not to pick this one, because remember, 4% means 0.04. This one over here would be 40%. 0.4 is 40. So make sure you have correct decimal placement when you do these, when you're converting from percent to decimal. Okay, next one. A party rental company purchases a van to transport party items to and from parties. They purchased the van for $20,000. And the van, so that's our P. Oh, let me write my formula up here. Well, wait, hold on. Let me keep going. The van depreciates, so that means we're going to have a minus sign, at a rate of 9% each year. So 9% means that my R is 0.09. Each year means that we're only compounding once each year. write an exponential decay model, and then find the value after 8 years. So that's my t. All right, so we're going to have p and then 1 minus r over n to the nt. So a equals p is going to be 20,000. Then I'm going to have 1 minus, my r is 0.09 over 1 raised to the 1 times 8. So there's my model. And now let's calculate it. So I have 20,000. 0.09 over 1 is the same as 0.09, so that's 1 minus 0.09, which is 0.91, raised to the 8th power. All right, so now I'm going to use my calculator. And I've got 0.91 raised to the 8th. Comes out to be a very long decimal, so I'm going to do a bit of rounding. I got 20,000. But if you're doing it on your calculator, which you should be, to make sure you get the same thing as me, you can round it on paper when you're writing, but you don't have to round anything on, just leave the whole number on your calculator. Because right now the whole number is still in my calculator, and I'm just going to hit times 20,000 equals. And I get $9,405.05. So that's how much the van will be worth after 8 years. All right, let's try another one. This one's a little bit different. We have a Petri dish that starts off with 10 bacteria, and the bacteria population doubles every hour. So how many bacteria are in the Petri dish after 8 hours? So we're going to start with our 10 bacteria. And then in order to write an exponential function that doubles, that means that what I'm going to have to multiply by are powers of 2. So I'm going to have 10, which is my starting amount, times 2 to the t. 2 to the t is the function that represents doubling, right? Because I keep multiplying by 2, by 2, by 2, by 2, over and over every hour for whatever number of hours they give me. So now we're going to plug in 8. 10 times 2 to the 8th power. All right, so 2 to the 8th, you can do it on your calculator, is 256. So I get 10 times 256, and that would give me 2,560. That's how many bacteria would be present in the Petri dish after 8 hours. All right, another investment and interest question. How much will your investment of $18,100 at 13.6% compounded quarterly be worth after 7.5 years? So I'm going to write my formula up here again. It's growing, so I'm going to put a plus sign. And now let's figure out what all of our variables are. This is my starting amount, so it's P. This is my rate, so my rate would be 0.136. It's compounded quarterly, which means every quarter. There are 4 quarters in a year, so it's compounded 4 times per year. And we're going to look at it for 7.5 years, which means my t is going to be 7.5. So now let's fill it all in. A equals 18,100 times 1 plus 0.136 over n, which is 4, raised to the nt. So raised to the 4 times 7.5. All right, let's simplify this a little bit. Inside the parentheses, I'm going to do 0.136 divided by 4, and then I hit equals, and I get 0.034, and then 4 times 7.5 is 30. I can simplify this further, and I get 1.034 inside the parentheses raised to the 30th power. So now I'm going to do, on my calculator, 1.034 raised to the 30th equals, and I get a big long decimal. It's approximately 2.7265669. But I'm going to keep it in my calculator, right? Keep it there, because all I have left to do is multiply by 18,100. So now with that big long decimal in my calculator, I'm going to hit times 18100. And I get 49,350.86. When it's money, you always need to round to the hundredths place. And that's it. All right, let's try one more. 550 is invested in an account earning 6.6% interest compounded continuously. What will the balance be in 10 years? So 550 is going to be our principal amount. 6.6% means that our R is going to be equal to 0.066. Compounded continuously means we have to use, the PERT formula, and the balance in 10 years means that my T is 10. All right, so let's do this. A equals P, which is 550, times E to the 0.066 times 10. Well, it's easy to multiply by 10 because it just means move the decimal over 1. So that's going to be 550 times E to the 0.66. So now on your calculator, the tricky part is figuring out where the E is. So if you're using a smartphone, you're going to need, you probably already know this, but to get to your scientific calculator, you have to turn your phone landscape. And if you turn your phone landscape, you'll have an e to the x button. If you're using the computer calculator, it's a little bit trickier, but you have to check off the inverse box. Once you check off the inverse box, then you'll see that you have an e to the x button. But you won't see it until that's if you're using the computer calculator. You won't see it until you check off that little box. So I'm using the calculator on my iPhone. So I have an e to the x button. So in order to use the e to the x button, you have to put the exponent in first. So right now I'm going to enter 0.66, and then I'm going to hit e to the x. And you should get about 1.93479. So try that now. Make sure that that's what you get when you raise e to the 0.66 power. Then once you have that number on your calculator, hit times 550. And we get, right, approximately 1,064 and it would round to 1.4.